So, hello everyone. Can you guys hear me? So, welcome back to our second session. So, we see that is a good retention. People coming back for the second session is great. So, you're enthusiastic to learn. So, before we start second session, Dr. Jiran starts second session. People have been asking questions about last week announcement about our programs. They like to learn more detail. I will give very brief details about our mentorship program. So I will just share the screen and talk about it briefly. So for Magnimind Academy, we've been giving mentor-led data science internship program. It is a boot camp with internship experience with several mentors. We provide several mentors, 3 to 5. We have unique projects. We open our data science portal. We have so many lectures that students can learn from. And we combine students with the industry experts. So generally, we've been facing 3 gaps in real world application. There's limited mentorship, lack of experience. These are the 3 main things that students have a hard time to get job. And we've been doing that like almost 8 years, just focus on data science and AI. And we see that 3 problems people are facing. And that's why we address that one with our bootcamp. Our bootcamp offer real world projects, 5+ mentors, both from industry and academics. And then we give a company experience. You work in a company settings and the second half of the project. And plus, all our experiences from Silicon Valley, that's where we're located. So we give the Silicon Valley experience, most trending technologies and topics. We keep up with the technology, almost recent requirements of the companies, what they look for, what they need. So overall, our mentorship-led data science bootcamp. And it offers projects, mentors, practice interviews, career coaching. We have interview Q&A sessions, resume support, connection with the recruiters, and so many lectures. If you guys have any questions and like to learn and schedule a meeting with us, please just send us an email or schedule a short interview with us if you're a match for the program or not. Now I will let Dr. Jaran start.
Thank you, Dr. Baday. Good morning, good afternoon, good evening. Hello, everyone. So welcome to the second session of our Pandas workshop. So as I talked to you guys, as I told you last time, this workshop was originally scheduled for 2 sessions. So now we are planning to have 4 sessions. So this is gonna be the second of 4. So we're gonna meet next week again this time, all right? Let me share my screen. You don't need any file, any data file. We are going to work on an exercise soon. At the time, you're gonna need a data file. I already shared the link to the material last week. So again, for those who just arrived or lost the link, I'm gonna share the link again. But for now, you don't need anything except your Jupyter notebook, or if you could open Google Colab, that'll be also fine, or any other tool that you are using to write your code. So let me share my screen. Okay, so and then when you have questions, please post your questions to Q&A rather than chat. So in chat, you can post your LinkedIn account if you want to share with other participants, or our Magnimind people can share links to our meetup groups or YouTube channels. But if you have any questions, share them, post them on Q&A so that I can see your questions. Otherwise, there are so many messages going on in the chat, so I may miss your questions. All right. So this is where we left last time. So first of all, let's remember what we did. We started with Pandas, and then we said Pandas has two structures, data frames and series. We started with series. We mainly last time talked about indices. That's where actually we left. There was one thing that's where we left, but the thing that we left with last time was interesting. So if you remember, so here is our original object. So it is a series, Pandas series, and then it has three elements. So blue, purple, and yellow. So these are the values. These are the values of this series. And then 0 to 6 are the index numbers. Again, remember, we have three elements. The first element has an order index of 0 and also an index value of 0. The second element, purple, has an order index of 1, but an index value of 2. So these are two different things. Again, we're going to come back to this shortly. Today, we're going to spend some time on this again. So then last time we said, look at the indices. We have 0, 2, and 6. We said, can we use reindex to fill in the empty spaces in between the indices? For example, between 0 and 2, I might have another index value 1. Right? So what I can do is I can reindex my original object, which is object 3. When I reindex, I am assigning new index value. So this part is, for those just learned about this, might be a little bit tricky. The reason is I'm not assigning new index values here. I'm repeating, I'm not assigning new index values here. What I'm doing is I am adding new indices to my series. When I do that, I am going to carry the index numbers from the original data sets. If these index values are among the new index values that I'm adding. So let me repeat this part, because at first we can be confused, and then I see some first time. Can you post the links? Yeah, sure. I'm gonna post the link, but for now you really don't need anything for now. Let me just post this. I'm starting from this 182. Increase the font size, sure. So let me do this. For those who just joined today, let me add these lines, and then I'm going to copy this content of the cell, post it on the chat so that you can quickly copy and paste and then be part of this discussion. So I'm going to import Pandas here. Import Pandas as PD, and then import NumPy as NP. And then let me share this. We just copy and paste this so that you can welcome. And then so link to the collab. So hold on, let me just 1 second. From chat, I am sending the content of the cell. So those who just joined or missed last time, so you can just copy and paste it, and then from there you can follow us. And for Colab, please search Google Colab. Google Colab. Okay. So when you search, because I already opened Colab before, I see this link coming, but normally you're gonna have a link to Colab. Just when you click on that, it's gonna say welcome to Colab. You're gonna see this page. Let me see. Here, okay, I'm gonna click on this. And then you're not gonna see these files here, because these are the files that I already have been working on. So you're gonna see this. And then from here, you're just going to open, what is that? Open a notebook, okay? Oh, because these are the recent notebooks. Just 1 second. Let me see what was. New notebook in Drive. So this is your new notebook. Then again, you can just copy this text and then post it in here. Great. Yeah. Now you are ready to import. This is import. You are ready to run this. Okay. this. Yeah, and then if you want to see object 3, here is object 3. Okay, it's these are the what is it, values, and these are the indices. Okay, let me get back to my my screen. All right, so that's where we are. So these are the original indices. So object 3 dot index. I need to run this first. Okay. So these are the indices of object 3. And then if you want to see the values of object 3, and these are the values. It's an array of values, blue, purple, and yellow. So what I'm going to do next is, we did this last time, but let's just remember what we did. What I'm going to do is I'm going to create a range of values. For that, I'm using numpy's. NP is numpy. NP is numpy. Numpy's array range, a range. I'm creating an array of values starting from 0, and it's going to stop at 7. 7 is not included. So here I have an array of numbers from 0 to 7. 7 is a stopping criteria, so it's not included. So what I'm going to do is I'm going to give these numbers as my index values to this object 3. So object 3 as of now has indices 0 to 6. I'm going to re-index my object 3. When I re-index, I'm not replacing these guys. What I'm doing is I am populating index values with some additional index values. For example, 0 is already here. 1 is not. So 1 is going to be another index here. So 2 is already here. So 2, purple. But 3 is not. So 3 is here now. But because 3 doesn't have a corresponding value in the original object, it has not a number value. That means there is nothing there. So I have an index value of 3, but there is nothing, there is no value corresponding to index value 3. All right. So this way I am re-indexing my original object, object 3. But then the thing is, what I want to do is, how about these empty spaces? What am I going to do with them? Well, there are different ways. Again, today we're going to continue with this. There are different ways we can handle them. But one thing I can do is, and then this is a very common practice when it comes to filling in missing values for time series data sets. And there's going to be another session for time series data sets using Pandas. Okay, we're going to have a specific session for them. But a common practice is I can fill in these empty spaces with, let's say, in this case, previous value. For example, the value for index 1 can be assigned with the value of the previous index. So that's what I'm doing here. So what I'm saying is when I re-index my object by adding new indices where I don't have a corresponding value for, I'm saying, please fill them out. Please fill these empty spaces out with the previous value. So this is, in this case, let me see. Oh, this is backwards. So let me use fill first. So I'm going to be filling forward. That means blue will be assigned to the next available no value. And then there is a value here, purple. Then purple will be assigned to the next, and then next, and then next. So let's see what's going to happen now. As you see, blue is assigned to the next. So NaN is assigned with blue. And then we have purple, so we don't need to replace purple with blue. Purple is already there. And then anything after purple without any value is assigned with purple until the next valid value, which is yellow. This is forward fill. I can also do backwards fill. Means I'm going to assign yellow to all the not a number or non-values until the next value before yellow. So now let me run this. Now, as you see, yellow is assigned to all values up to purple, and purple is assigned to all values up to blue. So this is where we left last time. So when we apply forward fill or forward fill versus mode, so we apply forward fill again. I generally use this for time series data sets. For example, I have sales numbers for a certain day. Let's say the sales number is blue, and then the next day's sales number is missing, let's say. Okay, So what am I going to do? So there are different ways of filling in missing values. Again, we're going to discuss this. But for time series data sets, one way is because today's sale is correlated with yesterday's sale. So I'm going to fill in with today's sale. So when do you do forward fill versus backwards fill? Again, it's just a matter of I mean, how you want to proceed. So again, I don't see too much of a difference. So depending on the context. Right now, I cannot really think of any good example to tell you the distinction between forward fill and backward fill. But the idea is in both ways, what we are doing is we are filling in the missing values with the previous or the next value, thinking that the sequential data points are correlated. Okay, this is what we are thinking. Sequential data points are correlated, but I really couldn't think of a good example right now. Maybe if I can remember, I will share you, but not I couldn't think of a good example now. Okay. Before we move to the next topic, I want to clarify this. I mean, the following. So, what is the difference between reindex? Okay, so this is something again. By the way, let me tell this. When you try to solve a problem using machine learning models, all right. So most of the time, what I see is we simply train a model without really knowing. Most of the time, okay, without really knowing the mathematics behind the model. Sometimes I ask, why are you using this model? Why are you using that model? No clear answer. So people try different models and then pick the model that gives the best performance. Again, how you measure the best performance, that's another story. How you tune up the model, that's another story. That part, believe me, at some point is easier than preparing your data sets for training those models. Okay, so what I see is most of the time we don't know well how we can actually I mean, prepare our data set for training a model. So all these step-by-step, what is it? Pandas instruction, all that we are going through, right? So each one of them, I'm pretty sure you're going to use them at some point when you are dealing with data sets to prepare them for training a model. So when you are taking an interview, if in the interview they're expecting you to merge two data sets, aggregate them, and then maybe at some point re-index them or assign new indices. So you will receive some questions like that, and then we might have another session for dealing with multiple data sets only using Pandas for interview preparation. You are going to use all these Pandas methods, right? So it's very important that we actually absorb what each of these important methods are doing. Okay, so indexing is important. It's going to be important when you slice data sets, when you merge data sets, they're going to be important. So there are three things regarding indexing, okay, which we may get confused with. One is reindex. Again, I told you, reindexing is not assigning new index values, adding new index values, but there is one thing that we need to be careful. So let's look at this example. So what I'm doing is I'm creating a data frame, and then this is the values of my data frame. And then, by the way, I got this example from GPT. A lot of times when we create a made-up data frame, this is how people give us values. So let me tell you what this means. Here, this is an array of 6 numbers. Okay, this is an array of 6 numbers. And then what I'm going to do is I'm going to turn this, as of now, it is one-dimensional array. I'm going to turn this into 3x2 matrix. 3x2 matrix. How can I turn this into 3x2 matrix? Why 3x2 matrix? Because I have 6 elements. 3x2 matrix has 6 elements. The way I'm going to turn this into a 3x2 matrix is I'm going to reshape this single dimensional array into, so this reshape is a method. Inside this method, now I'm putting the tuple, which is the dimensions of my matrix, 3x2. Now, this array is turned into a 3x2 matrix. As you see, the first row is 0, 1. The second row is 2, 3. The third row is 4, 5. Now, these are the values of my data frame. Now, I'm going to assign to each column and each row index values. So columns are columns. Actually, these are the index values for columns. So column, the first column is A. The second column is B. And also I give index values. I can give index values to each row. If I don't explicitly say, here I can say index equals this, okay? For example, I can say A, B. If I don't say this explicitly, now I said that, let me remove this. If I don't do this explicitly, what happens is when I create data frame, each row is assigned with an index value with sequential numbers. Like the first one is 0, the second one is 1, the third one is 2. So let me run this first. Let me run this. So let's see the original data frame first. So this is my original data frame. Okay, this is my original data frame. You see, these are the values 0, 1, 2, 3, 4, 5. This is the columns, and these are the row indices. What I'm doing next is I take this data frame, and then I'm adding new indices to my data frame. So what are those new indices? So I say, yeah, these are the indices 0, 1, 2, but I only want index numbers 0, 2, 4. I only want index numbers 0, 2. 0 is already here. 2 is already here. 1 is not listed, so 1 is going to be excluded. So the row corresponding to index 1 will be excluded. And there is a new index number 4. So 4 will be added here. But because there isn't any value for 4 in the original matrix, 4 will be assigned with NaN values. Now, the new data frame, after reindexing, has 0 and 2 rows. 0 and 2 rows. And there is a new row called 4 without any values. And row 1 is excluded because when I reindex, I excluded row 1. I hope this is clear. I am not assigning new index values to my original data frame. All I'm doing is I'm adding new index values, or I'm excluding some of the index values. Okay, this is reindex. Right? So let's go to the next example. Let's look at the next example. And please feel free to ask questions if I know the answer. Okay, I'll try my best to answer. So let's look at this example. This time, what I'm going to do is, let's run this first. Let me run this first. Again, let's look at the original data frame. Original data frame, DF. So sometimes, this is one way of creating a data frame. PD data frame. I give the values. The first one is the value. Okay. And then I give the column value. If you like, you can give the index value too. This is one way of creating data frame. Another way of creating data frame is you can insert a dictionary. Okay, we talked about this last time. Let me take the dictionary out. First, let's check the dictionary itself. So this is a dictionary, right? In between the curly brackets, ID is the key. The next list is the value for this key. So ID is the key of this dictionary. Next list is the value for this ID key value. Name is the key. And then Alice, Bob, Charlie. This list is the value for name. Again, 25, 30, 35 is the value for age. So when I put this, the dictionary into PD data frame. Again, PD data frame is a method creating a data frame. You see this round bracket. What it's going to do is it's going to take ID, name, and age as it's going to take ID, age, name, and age here. ID, name, and age as column names. ID is the column name is the column name, age. And then again, I didn't assign any index values explicitly. Index values are assigned automatically. Okay, that's clear. So we are fine with this. So what I'm going to do next is, and this is a very common practice when you are dealing with data sets. Again, for time series data set, we're going to do this again frequently. What I'm going to do is, hey, I don't want these index values. right? Rather than using the automatically assigned index values, I'm gonna use one of the columns as index. For example, this column can be country. So each row will be recognized by the country name, or I can say ID number. Each row will be called with its own ID number. So what I'm gonna do next is I'm gonna take my original data frame and I'm saying, hey, from now on, set my index as the ID column. So the moment I say that, here is what happens to my data frame. So data frames, this index column is dropped. It's dropped. ID column is assigned as the index now. So ID is the name of the index column now. Now my data frame has two columns, name and age. So let's see. So I'm going to take df set index and then index. You see, these are the index values now. 1, 2, 3. The name of the index column is ID, and the data type of my index value is 1, 2, 3. If I say values, now the values are just Alice 25, Bob 30, and Charlie is 35. So ID is not part of the values anymore. Okay, that is a second thing. Set index. Set index is taking one of the columns and setting it as an index of the data frame. The third, reset index. That's another thing that we're gonna use frequently. All right. So let's see what's happening now. Again, here is my data frame, the same data frame. So let me run this. Let me run this, and here is my data frame. Okay, again, data frame is already ID. Oh, I see. So let's go step by step. Let's go step by step. So let me copy this, put it here, and then say df. So my original data frame has, again, 3 columns, ID, name, age, and these are the indices. Next, what I'm going to do is I'm going to take my data frame. I'm going to say set index. Okay. I'm going to set my ID as index. Now, if I do this, look, if I do this, as you see, when I run this, I see that ID is the index, name, and age are 2 columns. Now I'm going to print df one more time on the screen, but I see that df is not changed. Okay, df is not changed. df still has index value 0, 1, 2, because what I did is I just see here what happens if I apply set index on df. This is what happens, but my df has not changed. So if you want to see this change be part of your df, if you want to really change your df, then you say, whatever happens now, make this in place. That means make this change the original data frame as you show me what would happen if I apply this function, this method on df. So again, I'm checking my df. Now df is changed. Okay, now ID is 1, 2, 3, and then I have name and age. Okay, so this is the second piece, set index. We already know. But then I realized, yeah, I did some work on the data frame and then say, hey, I need ID back as one of the columns. Okay, so I don't need ID as an index anymore. I want my ID back into my data set as one of the columns. So how am I gonna do that? Again, there are different ways of maybe doing this, but one way is what we are gonna do is we're gonna reset our index. So when we reset the index, what happens is it just gives the automatically assigned indices one more time and then puts ID back into my data. Let's see. You see, ID again is part of my data frame, and the new indices, the indices are reset, means the indices are again automatically generated. So let's see what here happened. You see, again, df is not changed. So let's say in place. Now the change happened originally, or the change happened actually on my data frame. Okay, so this is set index, reindex, and then reset index. Okay, so these 3 methods that are related to indices. Let's continue. Can you link the files from the previous session? Again, I'm going to share the link soon, Navi. So right now, you don't need any files for following up. So we're just going to type the code together. There is nothing actually required as of now, but I will share the data file soon, maybe in the second session. Okay, now let's create a new data frame. Okay, a new data frame, and then we'll continue with reindexing. Okay, so what I'm gonna do is I'm gonna create a data frame. So now please type the code so that you also will practice with me. Okay, so again, this data frame, I'm gonna create numbers from 0 to 9. 9 is not included, and then I'm going to turn this single dimensional array, which is 0, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to turn this into a 3 by 3 matrix. Reshape this 3 by 3. So let's see what happens now. So this is what happens. So as of now, as you see, I didn't say anything explicitly about index values or column names. So automatically, indices are generated for each row and each column. All right. Now let's give the index values ourselves. Index is a list of, so this index will be the indices of the rows. It's going to be A, and then C, and then let's say D. Okay, so let me run this. Let's see what happened. You see, I changed the indices of the rows. And then let me also give the column names. Columns. Okay. Ohio, Texas, and then California. Okay, let me run this. Now I have a data frame with index values for rows and index values for columns. Let's call this df. All right. So, and then this is our df. Let's keep our df in front of us. So what I'm going to do is I'm going to reindex. Let's reindex them. df. Now we know what reindex does. I'm just going to add new indices here. If those new indices happen to be indices that are already in the data set, the corresponding values for those indices will be there. Okay. So I'm going to reindex this. So my indexes. Here is the new index values. So A, okay, B, C, D. Now look, A, C, D are already here. D is not. That means I'm going to create a new row without any value. So let's see. Let's assign this to df2. df2. Okay, as you see, the second row is here without any values. Okay, so we already knew this. So can I also change the column names? Like Ohio, Texas, California, can I change the column names? Sure, why not? So what I'm gonna do is I'm gonna say states, another list. Let's say Texas, okay, Utah, and California. Okay, so next I'm going to say my df, which is my original df, and then I'm gonna say reindex. Okay, reindex. Again, reindex, but this time rather than reindexing the rows, I'm going to reindex columns. Same thing, but columns. Columns is states. So let's see what happens. Now, as you see, Texas is still here. But by the way, I did this on the original df, not df2. Let's make this on df2 so that we are not confused. Okay, so B is still without any values. But this time, Texas is here. California is here. I didn't include Ohio. Instead, I have Utah, a new column, and that column is a new column. So that's why I have all NaN values. Okay, I hope this part is clear. I hope this part is clear. Another way of reindexing is rather than saying columns or index, I mean, you can also say df2 dot reindex. Okay, states. Okay, so look what happens when I do this. You see, if I don't mention explicitly what these new index values are for, they are for rows or columns, by default, the rows are re-indexed. So I can say axis equals, if you say axis equals 1, the columns will be re-indexed. Let's see. You see, columns are re-indexed. If you say axis equals 0, the rows will be re-indexed. Okay, so that's another way you can re-index your data frame. Again, if this is hard to remember, then please just remember columns and index, these two keywords. Index is the index of the rows. Columns is easy to remember, index of the columns. Okay, let's see. Oh, okay, Rahul, I just saw your message. At what point, Anna is asking, at what point do we apply DF copy as best practice? Okay. So here is DF. All right. So in general, what is a good practice, what we do is when we are dealing with data sets, so let's say this is the original data set that we read. Okay, we read this data set from a file. And then now I want to do some work on this data set. One thing is, rather than doing changes on this data sets, I can say df, another df2 is df.copy. And again, this is not deep copy, by the way. So that is, it's a different thing. So now df2 is another data frame, which is the same with df. Now let me make a change on df2. So let's say df2 iloc 0 3. So what is that? Sorry. Oh, there is no index 3, 2. So df2 is 0 is the row number. The first number is row number. 2 is column number. So 0 is the row number. The first row, I'm looking at the first row, and then I'm gonna find the second numbered column with index value 2. Okay, so that means order index 0, 1, 2. I'm talking about California. Okay, 0, A, California, it's 2. So I'm gonna change this to 5. Okay, so now let's see df2. So df2 is changed, right? So that 2 is changed to 5. Let's see what happened to my original data set, df. df is not changed. Okay, df is not changed. Now let's do this. df3 is equal to df. Okay, so what is df3? df3 is exact the same with df. Okay, again, this is df3 and this is df. So df3 and df are the same. So same thing as I did, right? So I made a copy of df, assigned it to df2. So at this point, df2 and df were the same. Now I changed df2's one element. Now df2 has a value of 5 for California A California, but df has still the value of A California. It still has the value of 2. Next, what I'm doing is I'm assigning df to df3. So what happens as of now is these two variables together, df and df3, they are both pointing towards the same data frame. But here, df2 and df are pointing to two different data frames. That's why when I made a change on df2, this change did not happen on df, because df2 and df are pointing to two separate data frames. But here, df3 and df are pointing to the same data frame. So let's see what's going to happen. Again, I'm going to do the same thing, df3.iloc. iloc is, I'm using the order index value. So iloc 0, again, the first row, df3, first row, and then the third column, okay, which is 2. I'm assigning 5. Okay, now let's see what df3 looks like. df3, 2 is changed to 5. I'm just curious what happened to df. Wow, df is also changed. I didn't change df. I'm thinking that I just made a change on df3, but the same change happened on df, because df3 and df are just two names, pointing to the same data frame. Whatever change I made on DF3, thinking that it is only DF3, no, I'm making the same, I'm changing the same data frame that DF is also pointing to. Okay? So that's why using copy is going to create a copy of the data frame where you can do changes on this copy, and that change will not be happening on the original data set, right? Okay, let's continue. Let's continue. So I just used ilog here. When I use ilog, I'm using index values, this order index values. If you like, you can also use, so df, if you like, you can use also log, right? So for that, you need to be specifically saying the index value. So I can say A, which is the first row, and I can say California. This is the same with saying df dot ilog 0, 2. Again, please be very clear about this. Log, I'm using the index values. Ilog, I'm using the order index. So this is the first index, 0. This is 1. This is 2. This is 0. This is 1. This is 2. Okay. So if you like, you can also select multiple elements. So df log. These are things we will do frequently. So I'm going to select A and D. Okay, let's do it. A and D. So as of now, let's see what happens. You see, I selected A and D rows. Okay. And then from these rows, let me only select Texas. Now I have only Texas. From A and D, I only selected Texas. Let's select Texas and California. 2 states that I lived in. California. Okay, now I selected Texas and California. All right. Okay, let's continue. Please let me know if you have any questions at any point. So let's now create a new another series. This time we are going to look at, yeah, we looked at how we can slice our data sets using what is that in this index values. So can we drop certain values from our data frames or series? So let's begin with series. It's important to understand what's going on in series because data frame is stacked series actually, right? So let's create a series. So ed.series. Again, I'm gonna use numpy a range 5. So if I do this, it's going to create a series. These indices are automatically assigned, and these are the values from 0 to 5 is not included. Now I'm gonna assign index values. Okay, let's see. Now I have the indices and the values. So let's say this is my object. And then we know what object looks like. Okay. Now what I'm going to do is I'm going to take this object. Okay. And then I will drop from this object, I will drop C. When I drop C, I'm actually dropping the value, this row from here. Okay. I'm going to drop C. So now this is my new object, but again, my original object is not changed. Okay, my original. If you like, you can assign this to a new object, object new. Okay, so let's see what this new object is. Oh, now let's do this. Let's do the following. Let's see. I'm just trying something. I'm going to change this new object's first value. Okay, A. Right now it is 0, but I'm going to make this 9. Okay, let's see. New object. Now it is 9. Let's see what happened to my original object. Did it change? It didn't change. Okay, please keep in mind what I'm doing here is when I drop C, the value for C from my object, I'm assigning the remaining to a new object, this one. And this new object is a new series. It's not the original one. So, okay, so please be careful about that. So when I'm making a change here, the same change is not happening the original object. All right. So if you like, you can drop multiple elements. If you like, you can drop multiple elements. Let's just try object.drop. If you want to drop multiple elements, put them in a list. Okay. Again, I'm dropping elements based on their what is that? Index values. So I dropped the A and D. Okay. All right. I think this is clear. I think this is clear. Now let's do the same thing with the same thing with data frames. Sometimes when you copy the original data frame like df and use I love to change a value, it gives an error stating value is changing on a copy. Yeah, Nilesh. So we are gonna yeah, that's a very common error. We are actually I have an example on that today, Nilesh. So I have an example on that today. Not exactly what you described, but similar. Let's see why that error is happening. Again, I frequently have that kind of an error. Okay, so you want to make a change on you take a slice from your original data set, you want to make a change on that slice, and then it says there is an error. You're trying to make a change on what is that? On a copy. If you want to make a change on your data frame, use this, right? So you receive an error, and then they also make you a suggestion. So we have one example on that. Hopefully today we'll see that. Okay, so let's continue. Now what I'm going to do is I'm going to create a data frame. Data frame. Okay, again, I will use, now we are an expert on this A range, right? And then I'm going to reshape this. This time it's going to be 4x4. So this is how it looks like. Now let me give the values for, again, we know what it is now, right? So index is, let's use again, state, Ohio, Colorado. And then Utah. And then New York. Okay, so let's see. Here we have the names of the rows, and then let's also change the columns. This time I'm going to use words. Okay, 1, 2, and 3, and 4. Okay. So here is my data frame. So let's make this data frame df. Then this is my data frame. Okay, perfect. I have my data frame. So from this data frame, I can do a lot of things. So I can drop columns, I can drop rows, right? Again, most of the time you are going to receive a full data set when you deal with data sets. This data set will have data features and your target variable. So what we do is from df, we are going to create 2 different sets. One is going to be your feature set. The other one is going to be your target value, right? So for this, most of the time we use drop, right? Again, it's not the only way we do it, but you can definitely divide your data frame into X and Y using drop. Okay, so I'm going to take my data frame and I'm going to drop this one of the columns. Let's say I'm going to drop 2. Okay. 2. So when I just say, hey, I'm dropping column 2, right? So it doesn't look, to me, there's nothing wrong here. I'm just dropping this. When I run this, it's going to give an error. So that's a very common thing. Again, if you're learning this the first time. So by default, drop is going to try to drop this from the rows. Now it's looking for 2 in the rows. There is no 2 in the rows. That's why it's throwing an error. So you need to tell them, hey, I'm going to drop 2 as one of the columns. So look for 2 as column names. Okay. So I will say axis. You can either say columns here, if you like. But I like using numbers. It's easier for me. 1 is columns, 0 is rows. Okay. 0 is row, 1 is column. I'm going to drop 2 as one of the columns. Now it will work. Okay. So it dropped column 2 from my data set. Okay. Now, can I drop two columns at the same time, sure, why not? df drop, that's gonna be, you may want to drop some unnecessary features from your data set. The thing is, make sure that you put the column names in as a list. So this is the first column I want to drop 2, and this is the second column I want 3. So I put the column names as a list. Again, I need to tell, hey, these are column names, okay? So now I dropped 2 and 3, 2 and 3 from my original data set. Okay, let's continue. Let's continue. Now, again, going back to this object. So let's remember object, the series that we created earlier. So I have 5 elements, and then A, B, C, D, E are the how to drop rows by giving certain conditions like rows in certain columns if we have 4 to be dropped. So again, Nilesh, we're going to get to that. So I missed it. What does, oh, Drew, this is nothing. This is nothing. I'm just giving an example. So this is your data frame. This is just text. This is just text, nothing. I'm saying that your data frame, when sometimes you receive a data set, let's say there is a data set called cancer, okay? So it's another very good example. It's cancer data set. The cancer data set has certain columns which are measurements of, say, an image. So there is an MRI image, and then people just gather the information from that MRI image, and then each piece of information is one column, okay? And then there is, so this cancer data set is composed of features and whether the patient had cancer or not. That is diagnosis. Okay, so the cancer data set, let's say it has 30 columns, 29 of them features, 1 of them target. So what we do is, from this original data set, this is what we do, right? So y is equal to cancer dot diagnosis, right? And then x is cancer dot drop. Let's say there is a column called diagnosis, and then I'm dropping column. So that's what we do, right? When you learn machine learning, this is one of the first things you always do, right? So what you do is you take the data set and then assign one of the columns as your target variable, and then drop that column from your data set and assign the rest to your feature set. This is a very one of the first things you do when you receive a data set. So that's what I just wanted to point out, that you can use drop in this case. You can use drop to drop any columns that you don't want in your model, of course. Okay, so let's get back to our original object. Again, these are the indices. These are the values for those indices. Okay, so what I'm gonna do is I can select one of the values. Again, we already saw that object B. So I just selected this value. Oh, by the way, there was one question Nilesh was asking, how to drop rows by giving certain conditions like rows in certain columns if we have 4, have 4 to be dropped. So let's say I want to drop 4, right? I want to drop 4. So how can you drop 4? So you cannot simply drop 4 in here. So you can drop either columns or rows. You can change 4, but you cannot drop 4. So if you want to drop the row where 4 is located, so what you can do is, let's just, this is df. Sorry, so I'm going back, but let's answer this question. So let's say I want to drop this row if one column is equal to 4, whichever row has the value of 4 for the one column, drop that row. Let's say somebody gave this task to us, okay? I'm writing the task, drop any row if that row has the value of 4 for the column 1. So this can happen, right? So let's say I want to drop all the data points where age is greater than 50. Or I want to drop all the rows where income is less than 20K. I want to drop all the rows where this. So there is a condition, right? So how can we do this? Again, we are going to do this together. Okay, we're gonna do this together today, but let's try to do it now. So I'm going to, first of all, we are not just going to drop it. We're not just going to drop it. We are going to create a condition. So from df, I will say df dot one say is not equal to 4. Let's see what happens now. What happened? I just dropped the row where that row, if that row has a value of 4 for column 1. I just did that, right? Just did that. So we're gonna come back to this and then discuss different. There are so many things we can do actually, creating conditions, and this is extremely important. You're gonna actually filter your data set based on many different conditions. Okay. All right. Where were we? Yeah, I selected a specific value for row B, okay, which is 1. Again, object, this is object. And then from object, I selected B, okay, which is 1. So if you like, again, this B is in order. So this is the first index, this is the second. So 0 index, 1 index. So if you like, you can also select the same value. Actually, let me create a new data series. So it's going to be better if I do this. Object equals PD series. So I created 257, and then let me get the index values. Okay, so this is gonna be better because otherwise we mix index values with these values. So I don't want to do that. Okay, so now I want to select the second element of this object, B, okay, which is the value of 5. Now I'm gonna select, I can select the same element by giving the order index, which is 1. Okay, so please be very, again, this is a repetition, I know that, but let's be clear about that. B is the value of the index. 1 is the order of this guy here. So this one, the first one, this is the second one. Again, this is the first record, this is the second record. The first record has an index of 0 order. The second record has an index of 1 order. The second in a record also has an index value of B. So I can refer to the second record using either its index value B or its order value, which is 1. Okay, we are clear about it. Now I can select multiple elements, let's say from objects. Look what I'm gonna do. I'm gonna select from the second, starting from the second one. This is the second. Look, this is 0, this is 1, this is 2. Let's first print it. So this is 7. From 7, from the second to, let's say, 4th. So 0, 1, 2, 3, 4. Let's make this 5. So now I selected C, D, E. You see, let's make this 4. Now I selected C and D. So I started from the second, which is the third one. Second means index order 2. 0, 1, 2, which is 7. And then 0, 1, 2, 3, 4, which is 10. 10 is not included. 10 is not included. Okay. Well, if you like, again, you can do the same thing. So object, if you like, you can select multiple by using a list of index values. So A, C, E. Okay. Again, I selected multiple ones. Well, you can create a condition. Now we are getting into condition. Now I can say, hey, select all the, what is that? All the records, let's say the value is less than or equal to less than 5, okay? What I'm gonna do is, again, I'm gonna select all the records if the value is less than 5. So first of all, let's do this. Which ones are less than 5? So I just created a Boolean array. This Boolean array tells me if the first record is less than 5. Is it less than 5? Yes. Is that so? Yeah, the first record is 2. The second one, is it less than 5? No, because it is 5. 5 is not less than 5. So first of all, I'm checking which of the records is less than 5. Then I'm gonna put this Boolean array, okay, inside here. Okay, so what it means is from my original object, give me the records which correspond to true values. That's what it means. Now I get only 2 records here, A2, which is the first one because it corresponds to true, and D0, D corresponds to true. The false ones are eliminated. So this is how we can filter our series. Yeah, df column name only works if the column name doesn't have a space. If it has a space, make sure that you use, so don't use, if the column name is, let's say, column name is name 1, okay? If that is the case, then you cannot use this. So what we're gonna do is, remember from last time, we need to use this way, right? This is how I select a column from my data frame if the column name has a space in between. All right. Okay, so let's continue. Let's continue. What I'm gonna do next is yeah, let me get to what is it, data frames, because it's gonna be more interesting. So let me just copy this data frame here. Where is it? Yeah, please just copy this, okay? Just copy this. I'm gonna post it on chat if you guys have not written it. So here it is. So I just shared with you in the chat. And by the way, oh, I should give a break. Do you want a break? We can have a short 10-minute break. If you guys are tired, we can have a 10-minute break, okay? So let's take a 10-minute break then. So it is 11:07. We'll be back 11. Right now it is 11:07. We'll be back at 11:17. Okay. All right. Hello, everyone. Let's continue. Okay. We have some cells here. Okay. So where were we? Yeah. So this is our data frame. So let's run this data frame first. Claim this. This is our data frame. So what we can do is we can select, as I said, certain columns. We already did this earlier. If you like, this is a column. If you want to see this as like a data frame, put this into a list. Okay. And then if you want to see multiple columns, put those multiple columns into a list. So as you see, I'm selecting here columns. You can also select rows, right? So there are different ways of selecting a row. But here is the interesting thing. Here is the interesting thing. I take my data frame. Again, this is my original data frame, right? This is my original data frame. If you do this, look, if I say 0, thinking that 0 is the order of the first row, I'm going to select the first row. So let's see what happens. It gives an error. There is no such name as 0 here. So if I say Ohio, again, it's going to give an error. There is no such name because it's looking for this column. So it is first searching for column names. Okay, but if you say 1, because we have a column called 1, now we are able to select. Okay, that's first thing. That's first thing that we want to observe. Second, let's say, again, let's go back to our original data frame. So these are things that you are going to experience when you are dealing with data set, believe me, many times. Let's say I want to select the first 2 rows, Ohio and Colorado. If I do this, which is interesting, if I do this, let's say from the first column, first row until the third row, but third row is not included. So this is the first row, 0, second row, 1, the third row, 2, third row is not included. When you do this, it works. It gives you the first and the second row. But if you just give a single row value, it's not going to work. Okay, just keep this in mind. What if I want to only select the first row? For that, you can use iLock. Okay, so if I do this, now it gave me the first row, 1, 2, 3, 4. Okay, it gave me the first row, 1, 2, 3, 4. Okay, I was able to select this first row if I use iLock. If you use iLock like 0 and 3, what it's gonna give you is from the first row, the third column. Okay, from the the fourth column. From the first row, 0 is the first row, 3 is the fourth column because 0, 1, 2, 3. The value is 3. Okay, that's another thing. Now, next, what I'm gonna do is from my data frame, what if I want to focus on the third column? So I will say 3. Okay, so this is the third column. This is the third column. And then I want to see, I have 1, 2, 3, 4 values in the third column, 2, 6, 10, 14. Which ones are greater than 5? Okay, which ones are greater than 5? So what it does is, for each row in the third column, which records are greater than 5? If it is greater than 5, it gives a true, otherwise false. I did give an example earlier for this. Now I'm going to take this, put into my DF. So here is my DF, my original data frame. And then I will only select the rows corresponding to true value here. Okay, so I'm going to put this condition here. Okay, now I'm able to select the rows where the third column has a value greater than 5. Okay, all right. Here is another thing. Here is my data frame. Now I want to see which elements are greater than 5. This is all I'm doing. Okay, let's see. This tells me, if it's true, tells me that that element, the specific element, is greater than 5. If it's false, that element is not greater than 5. Okay. Now what if I put this as a condition? Okay, please, that part is, again, I'm only going to select the true values. Okay, this is like a mask. I will only select the true values. The false ones, I don't want to select them. I only want to see the elements of my data frame whose value is greater than 5. Yes. Now, as you see, I'm only seeing the elements. So this is my original data frame. Okay, I'm only seeing the elements which are greater than 5. Those which are not greater than 5, I have NaN for them. Now, here is another thing. Okay, here is the at first might be confusing. All right, so what I want to do is any element which is greater than 5, any element which is greater than 5, like 6, 7, I want to assign a value of 5 to them. So it's like putting a cap. Okay, so let's say home prices. Any home price value greater than 2 million, I will put it as 2 million. Okay, so this can happen when you're working with this. So you can put some caps. So I'm going to assign value of 5 for any value which is greater than 5 in my data set. Let's see what's going to happen. Let's see what's going to happen. You see, I assign the value of 5 for all the elements which are greater than 5. So again, let's go back to our original DF. Of course, now there is no original DF. All of them are NaN now because none of them are greater than 5. So let me run my original data frame one more time. I want you guys to please recognize what's happening here. Look. First, this. When I check which ones are greater than 5, those elements which are not greater than 5, I see it's NaN. NaN means this guy, whatever the value is, it's not greater than 5. Now, when I assign a value to all the elements which are greater than 5, these NaNs are not affected. In other words, the values which are corresponding to this NaN. So this NaN is not the true DF. Right now, what you see is not the original DF. This is just a condition we created on our data frame. So based on this condition, only change the values, valid values. The non-valid values, you cannot make any change on them, okay? So that's what's happening. Now my data frame is changed. All the elements greater than 5 are, so this is, you can also call this a censored data set, right? So anything greater than 5, we don't know if it was 6, it was 7. It is censored from right? Okay. Let's continue. Any questions up to this point? Please let me know. Okay. All right. I think I'm just checking if there is any interesting thing that we missed. Okay, here is the thing. Here is the thing. Let me run my data frame one more time. So this one is interesting. Okay, let me run this again. Okay, so this is my original data frame. This is my original data frame. So let's say from this data frame, can you pick, I mean, the first row? So we already know that. How can I pick the first row? How can I pick the first row? So I can say ilog 0. This is the first row. Can you pick the first 2 rows? Sure. So 0, 2, 2. That means I'm going to pick the first row 0, then 1, 2 is not included. Okay, this is the first 2. If it's going to be first 2, you don't need to give me the index of the first row. So that means anything from the beginning until the index, order index value of 2, which is not included. Again, the same thing, Ohio and Colorado. I'm selecting first row and second row. First row's index value, order index is 0. Second row's order index is 1. 2 is not included. Okay. Now, can you select from this data frame only, let's say, up to the first three columns, okay? So the answer is sure, we can. How can we select the first three columns? I can say, I know that I can select rows, sequential rows like this. How can I select sequential columns like this? So for that, what I'm gonna do is this comma indicates to the right of the comma. So let's put the comma first. To the right of the comma, I have columns. To the left of the comma, I have the rows. Okay. So I want to select everything from the rows, for only these columns. Again, 0 is the first column, 1 is the second column, 2 is the third column. So if I want to select the third column too, let me make this. Okay, let's see what's going to happen. So as you see, this means I'm selecting all the rows corresponding to column 0, column 1, and column 2. So then again, if I say from this data set, can you select the second and the third row corresponding to second and the third column? Again, I want to see 5, 6, 9, 10. Okay. Can you select from this data frame the second and the third row, the second and the third column? So again, let's go back to our comma business here. Again, first of all, don't forget iLog. I means I'm using order index. So, okay, to the left of the column, I'm going to select the second and the third row. So that means from the first, which is 1, this index value for this one is 1, to 3. So 3 is not included. That means I'm selecting 1 and 2. So if I do this, I'm selecting the second and the third row. Okay, second and the third row. Now, I'm going to select from second and third. I'm going to select second and third column. Again, second and the third column. So 3 is corresponding to fourth column, which is not included. Okay, as you see now, I selected 5, 6, 9, 10. Second and third row and second and third columns. All right. So this being very comfortable with slicing your data set is very important. Okay, make sure that you are comfortable with that. To do some exercise on this. It's not so complicated. Again, there is no, you won't go wrong if you always use iLog, and make sure that when you use iLog, you make sure that you know that you are using order index. Okay. But if you want to be specific about the names of the rows and columns, then use iLog. Use log, not iLog, but use log. Okay. Next, what I want to do is from my data frame, let's say I selected everything, all the rows, not necessarily everything, all the rows up to the fourth column. Okay, that means I'm selecting the first 3 columns. From this first 3 columns, can you select the ones, the records, the rows where the column 3 has a value greater than 5? Again, df dot 3, you can either write this way, greater than 5. You can either write this way. So it gave me on the column corresponding to 3, the 3 column, which values are greater than 5. The first value is not greater than 5. Second, third, and fourth values are greater than 5. You can either do this way or you can do this way. Both will work. Just put inside the quotation. Okay. So this is a condition checking if the column 3, each element in column 3 is greater than 5 or not. So that is the condition. Next, what I'm going to do is, this is my original data frame. From this data frame, I'm going to select the first 3 columns. Okay, this is the first 3 columns. From these first 3 columns, I will only select the rows where the column 3 has a greater than 5 value. So first, I will select the first three columns. Then what I'm gonna do is I'm going to put this condition here. Now let's see what's gonna happen. Now again, let me remove this. Let me remove this so we see what happened first. First, I selected first three columns. From these three columns, I'm selecting rows where the column 3 has greater than 5 value. Again, we know what this condition does. Here we checked it. It's only checking which of the rows, these are the rows, Ohio, Colorado rows, have a greater than 5 value. Okay, let me run this. Now I have only 3 columns and I'm sorry, 3 rows. And these 3 rows, I only have, I eliminated in this case Ohio because Ohio has a value less than 5 for column 3. All right. Okay. Again, another example. Can you select, again, let's go back to our example here. Can you select all the rows where, again, the fourth column has a greater than, has a value of greater than 10? Okay, again, this is our data set. This is our data frame. What I'm trying to do is I'm trying to select all the rows, okay, where the last column has greater than 10 value, right? So how can you do this? Again, let's see if we can, okay. First of all, let's see if we can create a Boolean array for the last column. So df4 greater than 10. Okay. The last 2 values are greater than 10. The first 2 are not. Now, I'm going to use this to filter my data. Again, this is my original data. What was the question? Can you select all the rows where the last column has a value greater than 10? So all the rows. Now I'm going to put this condition inside. Let's see if this is going to work. Let's see if this is going to work. It worked. So I selected the 2 rows where the last column is greater than. So is this going to also work? Sorry. Yeah. So log, Boolean arrays can be used with log. So if you don't put log, it will again work. Or you can put log. It will work. But Boolean arrays, this one, is not work with ilog. Right? I'm repeating, Boolean arrays will not work with ilog. It will work with log. Okay. Here is another question. Again, let's go back to our original data frame. I'm writing the question, okay? Can you assign value of 3 to all elements of df? Let me just thinking how to word it. Where, okay, last column has a value greater than 5. So let me see. Can you assign value of 3 to go to all elements, okay, where the last column has a greater than 5 value. Let's see if this is what I made. Let's try to solve this. First of all, let's find the elements greater than the elements. When I say all elements of df where last column is greater than 5 means all the rows where last element is greater than 5, right? That's what it means. So df, okay, so df 4 greater than 5. So let's see what this is going to give us. Okay, it gave us this, right? It gave us this. Now, can I assign a 3 or value of 3 to this one? Let's see if this is going to work. 3. let's see what happened to df. As you see, I assigned a value of 3 to all elements for which, this is all elements of all the rows, all elements of all rows of df where last column has a value greater than 5, right? So last column has a greater than 5 here, for which 7, 11, 15. So the last 3 rows, right, are going to be, all the elements here will be assigned to, 3 will be assigned to these guys. That's what happened here. They all are turned into 3. Only the first row remained unchanged. Okay. Is there any course material shared? Alex, I haven't shared anything. So we just typing the code. Okay, there is nothing to actually, we don't need, hi Alex, we don't need anything as of now. Okay, all right, let's continue. Let's run df here one more time. Let's get back to our original df. Okay, this is our original df. Let's go all the way down. Now let's see if we still have original df. Yeah, okay. So let's see. I'm trying to see. Yeah, here's an interesting case. Please pay attention now. Please pay attention now. Here is interesting case. What I'm gonna do is, again, from my data frame, let's say I want to see if anything on the second row, second column, is equal to 5. Okay, df2. Sorry. So this is the second column, right? This is the second column. I'm just checking if I have any of these elements in the second column is 5. So it gave me false, true, false, false. True means this guy here, second one, in this column, the second element has a value of 5. All right. Then what I'm going to do is, from my data set, all the rows for which the second column has a value of 5. In this case, only Colorado, right? Colorado has a value of 5 for the second column, others don't. Okay, so what I'm going to do is I'm going to select that column, and then I will change the column 3 of that column to 10. Okay, I'm writing here. Change column 3 value to 10 for all rows where column 2 has a value of 5. Okay, so this is our task. First of all, we are going to select the rows for which column 2 has a value of 5. And then for those rows, I'm going to change column 3 value to 10. That's my task. Okay, that's what I want to do. Okay, let's try to do this together. Okay, let's try to do this together. And this is a very common error I also receive from time to time. Okay, so common and time to time is contradicting, but yeah, I from time to time, I was receiving this error very frequently now from time to time. Okay, so here is what my first reaction would be to this question. So from my data frame, first of all, I know how to check which elements of the second column, which is 2, which elements of the second column, which is 2, has a value of 5. Okay, I already checked that one. Then I'm gonna select all the rows which satisfy this condition. Okay, so I will put this condition inside my data frame. Okay, this is the condition. So when I do this, I am able to get the only row where the second column has a value of 5. Okay, I'm fine up to this one. And then from here, think of this as a data frame. That's what I'm thinking now. From this data frame, I will select column 3. So that's what I'm doing now. I'm selecting column 3. Okay, so let's see. So I selected column 3. Okay, so this is 6 here. This is Colorado row where it has a value of 5 for column 2. And from this row, I'm selecting column 3. That's what I did. Okay, everything is perfect up this up to this point. I want to change this value to 10. That's what being asked from me. Okay, I'm pretty sure this will work. All right, I'm pretty sure this will work. I run this and then I get this error. It's a very annoying error. Okay, so it says so I already checked everything up to this point. Look, I mean, I'm on it, right? So I already found what I'm trying to change. I already know that I need to change Colorado 6 to Colorado 10. Okay, I'm right here. But when I want to make this change here, it gives me an error. It says a value is trying to be set on a copy of a slice from a. So what it says is, what you're trying to do is you're trying to assign a value. So right now, let me remove this. Right now, what you see is a slice from your data set. This is not your original data set. This is a slice from your original data set. It's almost like you are just focusing on a certain part of your data set and you took it out. And then you're trying to change it, hoping that that change will be on your data set. So Python is detecting what we're trying to do. So what you're trying to do is you are trying to assign a value here. But what you are actually doing is you pick this value out and trying to change it. That's what you are doing here. This will not work. You're not going to be able to change the original data set. Now, how are we going to do this? How are we going to do this? So the easy way to overcome this is rather than first selecting the row and from that row selecting that column, let's do this simultaneously. Okay, so let's do that together. Yes. EF 2, okay, equals 5, comma 3, okay, and then for this I need to use iloc, right? No, lock. Remember, I'm using lock when I'm using the index or column names. Okay, so let's first of all let's see what this is. Again, I got Colorado 6. Okay, I got Colorado 6. Very same thing. You see, very same thing. But this time, let's see if this is gonna work. And it worked. Let's see what DF is now. Hey, DF is now here. It's a 10, right? It changed. So this is one error from time to time I myself always get annoyed with. Okay, so just be aware of how you can address this issue. Again, let's also try to do this a little bit different. This time I'm gonna change the value back to 6. Rather than using lock, can we use iloc? So let's do it. Let's try to use iloc and then see if it works. Okay, so DF, rather than saying DF2, can we select this second column? Can we select second column here, right? That iloc. Okay, and then whether this is 5, comma, rather than saying 3, 0, 1, 2. Let's see if this is gonna work. And it didn't work. Let's see what. Location we can only have integer style. Endpoint is excluded. List like of integers. Boolean array types. Okay, so it gave an error here. Okay, all right. So how about this? Is it gonna work? It still didn't work. So what we are trying to do is this first part is a Boolean array. This first part is a Boolean array. iloc is expecting index values rather than a Boolean array. Okay, so if I do this, it will again not work because this time log is expecting a column name from us. 2 is not a column name. So when I do this, then it will work. How about this? And then column 2, which is 1. It again worked. You see, so I'm carefully using lock and iloc here. So this is a good example, actually. Here I'm using iloc to select the row, the second column. Okay, the second column. This means this means all the rows corresponding to second column. So this is the second column. From the second column, which ones are 5? This is giving me a Boolean array. This one is giving a Boolean array. And then from this Boolean array, pick the true ones for the column called 3. This column called 3 and Boolean values here require me using lock here. I hope this part was clear. Okay. Let me see if any questions. All right. Let's continue. Let's continue. Yeah, there's so many things actually. I'm just looking at my notes. All right, but before let's do this then. Let's do this. So I know there are other things coming, but before we leave, let me share for those who just arrived, I'm gonna share the link to this file. This is what you need to have. I'm gonna share this to you. Okay, let me come back here. If you just arrived and then you didn't have the files, here is the link to the files. Please go ahead and very small files actually. So let's do exercise together, okay? Another exercise. We're gonna continue from where we left here. Okay, so in our next meeting, I'm not saying goodbye, so not yet. In our next meeting, we are going data cleaning. So, okay, that's the plan. I already prepared the notes, but we didn't have time. Data cleaning. And then following data cleaning, I'm looking at my notes. We are going to talk about join and then how we can combine data sets. Okay, and then hopefully how we can do aggregation and grouping. Later, I'm going to have another session for time series, okay, using Pandas, all right? But please now open this Pandas data manipulation file. This is, and this comes with this meteorite landings file, okay? These two, I need this one too, but let's open this Pandas. I got this from this GitHub address. So it's very good resources. I strongly recommend go and check it. This person, thanks to him, so we are using this file now. You can check his GitHub account and then go through the exercises yourself. But let's do this together for now, okay? So what I'm gonna do is I'm going to import this meteorite data sets. We already learned about it last time. Let me get rid of this. Let me make this bigger. Let's inspect it. So we are gonna read the data set first. So let's import, and that's SPD. And then what I'm gonna do is I'm gonna read a CSV file, right? So I'm gonna put the name of the CSV file, which is meteorite and underscore landings.csv. See, if I just run this, okay, if I just run this, it's gonna give me, it's just going to give me the first 5 and last 5 observations. Let me assign this to some name. Let's call this DF, data frame. Okay, so I have my DF as of now. So let's say how DF looks like. Let's check the first 5 observations here. DF dot head. Okay, this is gonna give us first 5 observations. Look, these are the indices automatically assigned. We can assign, for example, we can assign IDs as indices. We already know that. How can we assign IDs as set underscore index ID? That's all. We already know that. So we have some categorical variables. We're gonna deal with them in our next meeting. We're gonna deal with them. We have year. We're gonna deal with this year column in our time series session. And then we have some values for these 2 columns and then tuples for these 2 columns. Okay, very good. So how many rows and columns in our data set? df dot shape, right? So this is an attribute. Shape is an attribute of our data frame. We have 45,000 rows, and 10 columns. What are the column names? df dot columns. Now we know what column means. That's actually the index value of the columns. If you like, you can also say df dot index, and you know that this index is just an array. It's the range of values. So it's the range index starting from 0, ending at 4571. So these index values are automatically assigned. Okay. The type of data each column currently holds. So again, this is our data frame. So what I'm going to do is I will just say D types, data types. Again, we're going to talk about this in more detail, but for now, we know that if it is object, it means most likely it is string. It's going to be a category. If it is integer or float, that's a numeric column. So the second one, it's a numeric. So 1, 2, 6, 10, these are numbers. Okay. Reclass, these are categorical variables. These are categories, right? Name type, it's not, it's category, valid or invalid. So name type is a type, data type of object. Later, we're going to see how we can change data types. Okay. And then I can also do, this is another way to slice your data set. For example, if I want to know which data types are object. Okay. If you do this and then DFD types, it gives you a Boolean array. It assigns true value to the column name if that column is of object data type. So second one is numerical. We know that. So that's why the Boolean value for the second column is false. So now if I say df this, what happened here? Df dot log. So okay, so what I did is from my data set, from my original data set, first I checked the data types, and then I said, hey, give me the columns for which data type is object. For example, name is a column with data type object, but ID is not. Name type is a data type with of object. Reclass is a data, but mass is not. So you see, in my data set, I'm using log. Remember, I'm using log when I have Boolean array. This comma is to the left of the comma, all the rows. To the right of the comma, all the columns. To the left of the comma, I want all the rows. That's why I have this. Okay. And to the right of the comma, I only need the columns where data type is an object. Okay. So this way I slice my data set in a different way using data type. Okay. So you can also check the tail of your data set. So df.tail will give you the last 5 observations. You can say last 10 observations if you like. Okay, it's up to you. Okay, so let's select the columns with names, with name and poll. Okay, if you like, you can select a certain column. We already know that, right? We already know how to do that. How can we do that? How can we select the column with row? So what I can do is I can say df, okay, and then name. So if I just do this, I'm selecting the column with name, but it says name and poll. In that case, I'm going to put this in a list. We know that, right? Now we are working on a real data set, right? Oh. So here I selected from my data set, I selected only 2 columns, name and poll. All right. Okay. Let's continue. Can I select the rows between 100 and 104? Again, this is our data frame, original. So this time I'm going to select rows between 100 and 104. Now, be careful here. Okay? This 100, if it is an index value, then you need to use log. If you are sure that these guys are asking for 100 data point, 101st, 102nd, 103rd, and 104th. Okay, if that is what they're asking for, then all you have to do is we already did this, right? We already did this. 100. If they ask 104th as well, then it's gonna be 105. Okay, here 100, 101, 102, 103, 104. Okay, now look what I'm gonna do. Let's say df2 is df.drop. Okay, 102 x is 0. So what I'm doing is I'm dropping this 102 row, okay, and assigning the rest to a new data frame called df2. Okay, now let's see. Now again, I'm gonna do the same thing, df2 100 105. Look, 100 101 102 is not here anymore, but it still gives me 5 data points because this is giving me 5 data points in order, the 100, the 101st, 102nd, even though its index value is 103, 104, 105. Okay, so again, be careful about order versus index. Right? What if I do this? So this time, log is giving me on the here, you would expect 100, 101, 102, right? You would expect 100, 101, and 102. So it's using log. So it's giving me again, it's skipping the third one. So if I say this, so it's giving me an error. It says there is no such index value, 102. Let's say there is no such index value. If I change this to 103, now it works. It gives me this one, but 102 is not there anymore for the F2. Okay, let's continue. So we already talked about this, iLog. Okay, let's use this one, filter with Boolean masks, and then I'm gonna let you guys go, okay? So it says, create a Boolean mask for meteorites weighing more than 50 grams. Again, let's remember how our data set looks like. Okay, here is the mass. So I only want to, I want to create a Boolean mask for meteorites whose mass is greater than 50 grams. How can I do that? Clearly, I'm going to focus on mass G, right? So df. Now, this has a space in between, so that's why I'm going to use brackets. Let me copy this. We are going to stop shortly, okay? And then let me put this inside. Now I am looking at this column, mass G. Now, if I say this is greater than 50, I created a Boolean value, right? False means 21 is not greater than 50. True means this one is greater than 50. Okay. So another one, let's do another one. This time, let's say, let's focus on fall, by the way. So ds dot fall. Second. Okay. So this fall column has 2 unique values. It's either fell or found. There are only 2 unique values. So because the first 5 observations are just fell, don't feel like there is only 1 value. There are 2 values. Okay. So the next one is I want to see if I can create another Boolean array for this column, fall. This time I will create a Boolean array for this column if fall is equal to found or not. Okay. So again, yes, this is my data frame. I will focus on all column. I'm just checking if the value is found or not. Okay, so the last ones were found. The first 5 were not found. Okay, all right. So I know now I can create 2 Boolean arrays for two different conditions. Now, can I put them together? Can I put them together? In other words, can I create a mask which is going to allow me to select data points where its mass is greater than 50 and its full value is equal to found? Can I do that? The answer is yes. So what we can do is we are going to, let me copy this, and then please you also copy. I'm going to take this, put this, and then I'm going to put these inside a parentheses and this AND operator. And then I'm going to take this guy and put it here again inside a parentheses. So what I'm doing is this time I am actually multiplying the corresponding. So false times false is false. True times false is false. So I'm trying to check creating a Boolean array, which is only going to give me value true if it is true for both conditions. Okay, here there are rare cases where it is true for. So what is that true means? The true means this meteorite, the index value 45711, has a mass greater than 50, and also it was found. All right. Now let me make this mask, because you are going to do hundreds of this when you are dealing with data sets. Okay, we're going to create masks for different conditions. Now, using this mask, what are we going to do using this mask? What if I do this df mask? Remember, this mask is giving you a true value for those meteorites whose mass is greater than 50 and its fall value is equal to found. You see? So I selected a subset of my data set. These are the index. You know, you're an expert on index values now. So let's focus on this last one here. Its mass is greater than 50 and its values, you see, all of them are found and all of them have a mass greater than 50. Okay, we just filtered out all the data points. Either their mass is less than 50 or either their fall is value is not found. Either. Okay, so we just eliminate. Okay, let me stop here. Okay, we are going to continue. Let me stop here. Thank you so much for listening. And again, I'll be here next week as well. And we're going to continue with data cleaning and preparation. And then if time permits, we're going to continue with this exercise, right? So have a nice week and then take care, guys. Thank you for listening. I'm going to put a copy of this worksheet into the same folder. Okay, bye. Bye. Thank you.